Hey guys, let's do some physics. Get your homework out. Let's look at number one. First things first, see the word proton? All right, the charge of a proton above it. That's that 1.6 and 10 to the minus 19 coulombs. Next up, I see a mass there, okay? Then I see the word stationary. Stationary means it's not moving, which means the forces are balanced. Uniform electric field. That means the electric field is not changing. It's a single value. It doesn't change based on distance. It's just a number. Take into account gravity. Okay, gravity is negative 10 or just 10 downward. I don't care about negative and positive when it comes to charge. And I'm going to find the field, which is letter E. So the first thing I recognize is that there's a force downward because it's in gravity. And that force is mg. If you do the math with the mass above and the gravity, which is 10, you get just 1.67 times 10 to the minus 26. There's an upward force. In order to be balanced, there's got to be an upward force. Where does the force come from? The force comes from the other field. The other field is the electric field. So the upward force is to be the exact same as the downward force. Even my categories. Now finally, we're going to do field is force over charge. I know the force is the previous number, and I know the charge I wrote down as the charge of a proton. And with that, you get the final answer, which is in newtons per coulomb. Okay, next up, we have two spheres with a charge of negative q, positive 2q. They have a distance. The distance changes. What happens to the force? Notice you don't see the word field here, so we can't use the force over charge equation. And this is comparison. All we're given is charges and distance. So I'm going to use the electric force is kq1, q2 over distance squared or r squared, same thing. Since it's comparison, we're just going to simply look how things compare and cross them out. The k doesn't change, the charges don't change, the distance triples. And a triple squared is 1/9 the force. Then finally, we're going to look at this picture. Consider the electric field lines shown below. Okay, those are a bunch of lines. Rank them from the smallest to largest fields. Fields are stronger when the lines are closer together. When the lines are super far apart, that means there's very little field. So C is going to be the most field. Next up is going to be B, because B is where the lines are closer together. Next up is going to be E, then A, and then D is the dead zone, so it's last. Even though A is on a line, it doesn't matter. It's about how the lines themselves are close together. Now flip to the back. We see here, find the net field and direction on the arrow. So the arrow is going to be that point I'm looking at. I draw a little point there to remind me. The positive, that one has a field going out. So at the point, its field is going to be out, which is to the right for that charge. I'm going to call that the first field. Now, looking at the second one, its field is also out because it's positive. So out at that point is again going to be to the right. So that's the other field. Since both fields are to the right in that point's case, we're going to simply add them up. But first, we got to find the amounts. kq over r squared, that's my r. It's not radius, it's distance. K we know. Q is in micro, so we're going to do that 10 to the minus 6. And the distance, we're going to convert to meters. Now, when I find that out, that is 2 million something. And that field is right at that point because it's going away from the positive charge. Now for the other one, I'm going to do the exact same equation but different numbers. Five micro, and then the distance is the entire thing. Now we're going to assume that that circle doesn't really play a role. It's just 42 and 19. And doing this, I get myself a much smaller number because it's farther away and it's weaker, but it's still going to the right. So if they're both going to the right, what am I going to do? I'm going to add them up. And that's how I get the total field is that 2 million blah, blah, blah. And it's going to the right.